Hello, welcome to chapter 3.3, the slope of a line. And we're going to learn in this particular chapter, how do we calculate the slope of a line? The slope of the line is the measure of steepness, meaning how crooked the line is. Calculating the slope of a line. The slope formula is what we call m. And m is equal to the vertical distance, or the up and down distance, over the horizontal distance, which is the right to left distance. Some people call it equal to rise as the vertical distance and run as the horizontal distance. And others call it delta y over delta x, which means the change in y over the change in x. And this is equal to, when we look at it in terms of points or coordinates, y2 minus y1 over x2 minus x1. To understand the rise-run terminology a little bit better, here we have a situation with a line on a graph and 2 points. And here's our first point. So we go up 4 boxes, and that's our rise. And then we go across 1, 2, 3, 4, 5 boxes, and that's our run. So our slope is rise over 1, which is equal to 4 for the rise, over 5 for the run, and that would be our slope. In example number 1, we're given 2 points, -3, 2, and 2, 7. We want to find the slope of the line segment joined by these 2 points. So let us go over to the whiteboard and work this out. In example number 1, we're given 2 points. The first point, the x part is -3, and the y part is 2. And the other point, x is 2, and y is 7. And we're asked to find the slope of the segment that joins those 2 points. So recall that the slope formula is m, where m means the slope, is equal to y2 minus y1 over x2 minus x1. Well, you may ask what that means. Well, let's look at each coordinate. Let's look at each coordinate or each point. Well, we can call this part x1, and this y1, and this part x2, and this part y2. And then we can plug it in. So we have y2 is 7, and y1 minus 2 is positive 2, but because we have to subtract it, we put 7 minus 2. And then in the denominator, we have x2, and x2, we have the 2 there. And then in the next one, we have minus, and I'm going to put it in bracket, minus -3, because x1 is -3. You want to be very, very careful of your signs, because this is y2 minus y1 and x2 minus x1. So now we're going to solve this. 7 minus 2 over 2 plus 3. Remember, negative and a negative is a positive. And that will be equal to 7 minus 2 is 5. 2 plus 3 is 5. So that means that our slope is 1. In reviewing what we just did on the whiteboard in example number 1, we had 2 points, -3 for the x and 2 for the y, and the other point 2 for the x part and 7 for the y part. And we label them x1, y1, x2, y2. And then we used the slope formula, and we found that 7 minus 2 is the y part, and 2 minus 3 is the x part. And then we found the slope is 5 over 5, and finally we reduced that to find that the slope was equal to 1. In example number 2, we're asked to find the slope of the line passing through the points -6, 6, and 4, 5. So let us go over to the whiteboard and work this one out. In example number 2, we're given the points -6, 6, and the other point is 4, 5. So we have the formula here for the slope. So we'll just put here x1, y1. And I do this so I don't get mixed up and confused when I'm doing one and like right, left, this, that. So I'm very clear. x2, y2. And then I find the slope m is equal to, well, what's y2 is 5. So I see that is 5 minus y1 minus y1 is 6. And that will be over x2. Well, what it is over x2? Well, what is x2 is 4 minus, and then minus 6. Remember again, I put it in the bracket to be very careful of my signing. So now I have 5 minus 6. Well, that gives me -1 on the top. And then 4 and a minus times a minus. Well, that'll give me 4 plus 6. And that will give me -1 over 10. And that will be the slope of the line that connects those 2 points. Reviewing what we just did on the whiteboard in example number 2, for the points -6, 6 and 4, 5, we labeled x1, y1, and x2, y2. And we used the formula and found m is equal to 5 minus 6, and for the denominator is 4 minus 6, which of course will make it positive. And this means that m is equal to -1 over positive 10. And this means that the slope is equal to -1/10. In example number 3, we're asked to find the slope of the line passing through the points 2, 5, and 7, 5. And we're also asked to figure out what type of line this is. So let us go over to the whiteboard and work this out. In example number 3, we are given the points 2, 5, and 7, 5. And as before, in order to find the slope, I'm going to label x1, y1, x2, y2, so I don't get mixed up. And the slope is equal to y2 minus y1 over x2 minus x1. And then, so I have y2, and that's 5, minus y1, that's 5. And then I have x2 is 7, and x1 is -2. as we subtract 2, because that's 2. Now notice that 5 minus 5 is 0. Uh-oh, what's going on there? And then over 5. Oh, there must be something wrong. Well, not really. What that means is that we have a horizontal line going through y. So we could draw that. If this is our y-axis, this is our x-axis. 1, 2, 3, 4, 5. So we have this is our line. Y is equal to 5. Reviewing what we did on the whiteboard, we found that for the points 2, 5 and 5, 7, and we labeled them x1, y1, and x2, y2. We found the slope using our slope formula, and we got the slope 0 over 5. But because 0 over 5 is equal to 0, this means that the slope is 0. So we found that because the slope was equal to 0, what this means that this is a horizontal line going through y is equal to 5. In example number 4, we're asked to find the slope of a line passing through the points -7, 6, and -7, -2. And we're also asked what type of line is this. So let us go over to the whiteboard and work out this example. In example number 4, we're given the points -7, 6, and the other point is -7, -2. We have all these negatives, so we want to be very, very careful of our signing because we have all these negatives happening. So again, I'm going to label x1, y1, x2, y2. And our slope, m, is equal to y2 minus y1 over x2 minus x1. So we have here -2 minus, and then y1. Well, that's just 6, but it's okay to put it in the bracket to be extra careful. And then x2 is -7 minus, and then -7. So here we have -2 and -6, so that gives us -8, all over -7 plus 7, which gives us -8 over 0. Oh no, it's over 0. Well, that means it's undefined. And when we talk about a line that's undefined, we talk about a vertical line. So what does that mean when we graph it? Well, that will mean that x is equal to -7. So if I was to graph that, one, two, 3, 4, 5, 6, 7, 1, 2, 3, and then put a few lines here. And so that means that x is equal to -7 would be a vertical line like this, and this would be our line, x is equal to -7. But essentially this is undefined, but when it comes to the graphing world, that means that it is a vertical line. In reviewing what we just did on the whiteboard in example 4, for the points -7, 6 and -7, 2, we labeled x1, y1, and x2, y2. We found the slope, and we found that the slope was undefined. Now, if we find that a slope is undefined, and undefined means that a 0 is in the denominator. And if a slope is undefined, this means that this is a vertical line passing through x is equal to -7. So we've learned that there are different types of slopes. This way, when it's pointing to the right, this would be called a positive slope. If it goes to the left, it's negative slope. If it goes from right to left or left to right, it's zero slope. If it goes up and down, it's undefined. We can use the analogy for a slope: positive slope, uphill ski lift; negative slope, down the slope; slope equals 0, cross-country skiing; and finally, undefined slope. Oops! The slopes of parallel lines. In number 5, we're given the points A, 2, 5, B, 1, 2, C, -2, 1, and D, -1, 2. We want to find the slopes of the line segments A, B, and C, D. And we want to also find the relationship between their slopes. So let's go over to the whiteboard and work this out. In example number 5, essentially we're asked to compare the slope of two lines. So we have line A and B, and they're represented by points 2, 5 for A, and then B is 1, 2. And the other one line segment would be represented by CD, where C is point -2, 1, -1, and point -1, 2. So we want to find the slopes of each of these lines, or line segments. So as before, we use our formula: m is equal to y2 minus y1 over x2 over x1. And so for the first line segment, AB, I'll label x1, y1, x2, y2, and then plug in accordingly. So I will get m is equal to y2 is 2, y1 is 5, and for the bottom I have x2 is 1, and then minus x1 is 2. So I get 5 minus 2 minus 5 is -3, and then 1 minus 2 is -1. And remember, a negative over a negative is a positive. So that's 3 over 1, and essentially that is 3. So our slope is 3. Now for our other line segment, we do the same thing. We have m is equal to, and I'll label again x1, y1, x2, y2. So I have 2 minus 1, because I want to be very careful of my signing. And then that's over x2 minus 1 minus 2, x1. So that's going to be equal to 2 minus plus 1. And then the bottom one is going to be minus 1 minus is plus 2. So that's going to give us 3 over 1, which is the same thing as 3. So we notice that these two lines have the same slope. So let's go back to the PowerPoint and see how they're graphed to understand that when they have the same slope, they are parallel lines. Reviewing what we did on the whiteboard, we found the slope of AB is equal to 3, and we found the slope of CD is equal to 3. This means that the slopes of parallel lines are equal. If we were to graph this, here's how it would look. Here we have point A, which is 2, 5. Here we have point B, 1, 2. Here we have point C, negative 2, 1. And here we have point D, negative 1, 2. We connect D and C with the red line, and we'll connect A and B with the blue line, and we can visually see that they are parallel to each other, which means that they're always equidistant from each other. In example number 6, we're asked to find the slope of a line that is parallel to the line segments joined by the points 8, 5, and negative 2, 6. So let us go over to the whiteboard and work this out. In example number 6, we are asked to find the slope of a line that is parallel to the line segment joined by the points 8, 5, and the other point is 2, 6. So as before, I'll label this one x1, y1, x2, y2, so that I can find the slope of them. And then I can figure out what a parallel slope would be. So as before, I have m is equal to y2 minus y1 over x2 minus x1. And I see that we have 6 minus 5. And then I have negative 2 minus 8. And I put it in brackets so I don't make any sign errors. So I have 6 minus 5, and that will give me 1. And then I have negative 2 minus 8, and that will give me negative 10. Or I can just write it 1, negative 1 over 10, 10th. Now, by definition, a parallel line, we'll call that M parallel, would be equal to negative 1 over 10, because parallel lines have the same slope as the other line, which we would call, let's say this is M1. Reviewing what we just did on the whiteboard, we found that M1 was equal to negative 1 over 10. So that means M2, meaning the second line's slope, will also be negative 1 over 10 because these lines are supposed to be parallel. Remember, the slopes of parallel lines are the same. The slopes of perpendicular lines. In example number 7, we're given points E, 2, 3, F, 1, 1, G, 5, 1, and H, 3, 2. We want to find the slopes of the line segments E, F, and GH, and then figure out what the relationship is between their slopes. So let us go over to the whiteboard and work this out. In example number 7, we're going to analyze what it means to be perpendicular, what line segments or lines, what it means to be perpendicular. So we have line segment EF, and E is 2, 3, and F is 1, 1. And then we have the other line segment, GH, where G is 5, 1, and H is 3, 2. And what we want to do is we want to analyze the slopes of these two line segments to see what it means to be perpendicular and how the slopes relate to each other when they are perpendicular. So we have M is equal to Y2 minus Y1 as before, and X2 minus X1. And I label each of these points X1, Y1, X2, Y2, and then X1, Y1, X2, Y2. And so I find the slope, let's call M1, 1 minus 3, over 1 minus 2. And I get 1 minus 3 is negative 2, and then 1 minus 2 is negative 1, and that's equal to 2 over 1. Now for GH, well, we'll call that M2. And we have 2 minus 1 divided by 3 minus 5. Well, 2 minus 1 is 1, and 3 minus 5 is negative 2, which we can write as negative 1 over 2. So we see that in order for lines to be perpendicular, the slopes must be the reciprocal, which means the upside down, and the sign must be changed. So let's go back to the PowerPoint and show how this looks graphically.
Reviewing what we just did on the whiteboard, we found that the slope of the first line, EF, was 2, and the slope of the second line, GH, has to be the negative reciprocal of the first line in order for it to be perpendicular. So the slopes of perpendicular lines are negative reciprocals of each other. Negative reciprocal means that we take the slope of our original line, flip it over, and change the sign. If we were to graph this, we see that our point E, 2, 3, our point F, 1, 1, our point G, 5, 1, and our point H, 3, 2. So we connect G and H with the red line, and then we connect E and F with the blue line, and we see they intersect each other at what's called right angles, which means that they are perpendicular to each other. In example number 8, we're asked to find the slope of a line that is perpendicular to the line segments joined by the point 8, 5 and negative 2, 6. So let us go over to the whiteboard and work this out.
In example number 8, we're given 2 points that form a line segment, and the 2 points we are given is 8, 5, and negative 2, 6. So we want to find its perpendicular, what the slope would be of any line perpendicular to it. So as before, I will label this x1, y1, and x2, y2. Doesn't matter which one you label 1 or 2, just so long as you're consistent in that this is always the x, the first one's always the x, and the second one is always the y. So I'll call it M1 is equal to 6 minus 5. And M2 is negative 2 minus 8. So that means we have 1 over negative 10, which is equal to negative 1 over 10. So we want to now find any line that would be the slope of any line that would be perpendicular to it. So we have to take the negative reciprocal. Well, the reciprocal is 10 over 1. And since this is a negative, the negative times a negative, and that would mean this would have to be a positive 10 over 1, which is 10. So the slope of any line perpendicular to this particular line segment would be 10.
Reviewing what I just did on the whiteboard, we found the slope of the first line is negative 1 over 10. So in order to make a perpendicular line, we have to flip this over and change the sign. So that means that the second line, in order for it to be perpendicular, must be 10. Remember, the slopes of perpendicular lines are negative reciprocals of each other. That means we have to flip the original slope of the line over and change its sign. So the summary of the slopes of parallel and perpendicular lines is that parallel lines have the same slope. Remember, parallel lines never intersect. And perpendicular lines have a negative reciprocal slopes. Remember, perpendicular lines meet to form right angles. Thank you very much. I hope that you enjoyed this video. Take care, be well, and goodbye for now.